T-minus 10, 9, 8, 7, 6.
Standing by to launch.
1, 0, and liftoff.
Looks like an Ariane 5 rocket taking off. It's pretty spectacular. Because the legs are generally in the mud, as it leaves the seabed, you get these trails of mud coming off which look like smoke, and it really does look like a rocket taking off. The oceans are huge. Sebastian is a small vehicle. We only have a finite amount of space on that vehicle. Throwing these landers over, this allows us to get 3 times the normal amount of samples. We can get more results and we can add more pieces to the puzzle that is understanding the oceans.
This is really exciting mud. It smells like you mixed a gas station with a bunch of hard-boiled egg yolks. I mean, it's those really interesting chemicals that make this site so unique. And the organisms, the microbes, and the animals that are able to eat these compounds is the reason why we keep going back to this place and studying it more. The problem is with ocean science, particularly deep ocean science, we know very little about how phenomena like these change in time. The equivalent of going to Boston in the wintertime and assuming that those 20 minutes that you observe the city of Boston in the winter as the way it is 365 days of the year. It's set up to measure the temperature of the mud in 50 different places, and we'll log temperature for 3 weeks. That helps us learn more about the ocean at a quicker rate.
It's nasty down there. I mean, if you look in here, it's oily, burnt, melted, gross. Everything smells like oil and sulfide out here. It's such a simple thing, you know. I think you learn about osmosis, you know, middle school or early high school, and yet here we are out doing cutting edge research using one of the most basic principles. This is 500 meters of copper tubing, and so it's filled with water from the bottom of the ocean, and so we're going to measure in sections the chemistry from the bottom of the ocean over the 3-month period.
And this sampler is the first long-term time series deployment in Guaymas Basin, and one of very few that exist in hydrothermal ecosystems. We deployed this instrument in an area where there were white bacterial mats and orange bacterial mats. When we went back today, there were no bacterial mats. Much, much different temperature regimes, much different biological regimes, and that's going to be just super, super interesting to compare.
These days on here now are precious. The lander expands that ability, expands the amount of science that we will get out of this expedition. But the time now is precious, and we're here to maximize that.